Hello, welcome, lovely greetings to all dear students. This is Navin Karki with another episode in physics. और आज हम बात करने जा रहे हैं a very wonderful but a little bit of confusing topic. बात करने जा रहे हैं about static friction. Now, if you have gone through static friction at least once, आपको पता है ये जो topic है कभी-कभार बहुत डरावना बन जाता है because there are lots of concepts where there are more misunderstanding than understanding. It's a fact. Maybe you would completely agree with me. कि बहुत सारे चीजें हैं जहां आपको लगता है as per the rule book it should be there, but suddenly you open up the book, you see the solution and you find different figure. तो आज क्या करेंगे? We are going to talk about static friction, and believe you me, by the end of the class you would be completely in a position to decide the direction of the static friction and the magnitude of the static friction. Now, शुरू में I said that the topic is very confusing. आपको असल में डराने के लिए नहीं है, just to make you a bit careful. Do remember this particular topic is the one which requires lots and lots of understanding, minute detailing and all those given things. As you know, if you are the old viewer of this, so class medium of communication we kept 80% English and little bit of Hindi, तकरीबन 20% हिंदी रखते. Class के दौरान if you have any sort of doubts, any sort of difficulty and you want to communicate with me, there is only one medium by which you can communicate and that is WhatsApp. आज technical support के लिए Rahul is there who would be helping me, who would be showing me all your WhatsApp communication. Okay, so let us try to see. Number 9311, let me write it, 9311883484. So this is the WhatsApp number. और आप कोई भी queries हो या ongoing class में if you have any sort of answer and that you want to post it, please post it only and only in this WhatsApp number. Let us begin. Lots of grounds to cover, so let's start. The first thing is that static friction को जब handle करना है, then we need to do it very carefully. Okay, so there I find someone writing hello. Okay. Hi, good evening. So let's start. All right, शुरू करते हैं. Let us see. So to begin with, let us see here. Static friction. नाम से अगर देखेंगे, that means something that is associated with rest, because we know the meaning of static is associated with rest. तो ये किस तरह का rest है and where will the static friction be acting? Let's try to understand. The first and foremost thing that you need to understand is static friction. Now, we'll go deeper and deeper into concept, and don't worry, we will go with plenty and plenty of examples, plenty and plenty of illustrations. My ultimate motive is that at the end of the class, you should be completely fulfilled. देखते हैं, let's start, all right? If I talk about static friction, the first thing is that static friction acts when there is no relative motion. That's the first given thing. Yani, if you have to decide whether in this given condition, the friction acting would be static or not, सबसे पहला test you need to do is you need to verify whether there is relative motion or not. और अगर relative motion है, let me be very careful in this. Motion की बात नहीं कर रहे, we are talking about relative motion. Relative motion किन के बीच में? That is the big question. Relative motion between, जैसे कि मान लेते हैं अगर आप यहाँ decide करना चाहते whether there is static friction or not, तो आप पहले देखेंगे if there is relative motion between the block and the ground. You get my point? Similarly, if you want to decide whether there is static friction or not, तो पहले आप ये decide करेंगे, ये investigate करेंगे. Now, when I say investigate, it's not that big, detective investigation. देख के आपको पता चल जाएगा कि whether there is relative motion or not. Now, if I want to decide यहाँ पर whether static friction is acting or not, तो आप देखेंगे block और ground के बीच में if there is relative motion or not. Similarly, let me add one more example. मान लेते इसके ऊपर there is another block M dash. And now you want to decide at this given surface whether there is static friction or not. तो क्या check करेंगे? Whether there is relative motion or not. किन किन के बीच में? Because I'm investigating about static friction here, so I would be looking at the relative motion between M dash and M. If I want to investigate on static friction here, then I will see the relative motion between M and ground. So I hope the first part is completely clear. जिस surface में static friction है या नहीं, if you really want to identify, तो आपको देखना होगा उस given point पे, उस given surface पे, relative motion is present or not. So I don't think so. Now this thing is at all going to be a trouble, okay? All right. लेकिन कहानी में थोड़ा सा twist है. There's a little bit of change in the story. ऐसा बिल्कुल संभव है कि relative motion नहीं है and the static friction is also not acting. Now here you have to be very very careful. यानी testing के लिए आपको दो चीज देखनी होगी. And testing for what? Whether there is static friction or not. पहली चीज, there should be no relative motion. दूसरी चीज, there should be intention, mansa, intention to have relative motion. So that's the second point. Let me write relative motion. यानी relative motion नहीं है, ये बात तो समझ आ गई. But there should be an intention to begin the relative motion. अगर ये दो properties satisfied है, then you can 100% say that is the correct environment to have static friction. Now you would say first point check करना ये तो एक आसान बात है. Just to identify whether there is relative motion or not, ये तो आराम से कर सकते. लेकिन intention, block का जो मन की बात है वो पता कैसे करें? That how to identify कि relative motion start करने का इरादा है. There is an intention to begin the relative motion. Now that is a little bit tricky. But let's just follow a simple technique, and with the help of that technique you can easily identify कि yes, at this point motion तो नहीं है लेकिन motion शुरू करने का इरादा है. So how to find that irada? How to find that intention? That is the big question. And it's very very simple. एक बहुत आसान तरीका है. Now here the condition is given, both the blocks are at rest. ये तो देख के समझ में आ जाएगा that this left block is at rest. इस given situation में it could be anything. ऐसा बहुत बार होता है, you are applying the force, still the block does not move. It can happen. You apply the force, the block may move. You apply the force, the block may not move. Both the situations are possible. और यहाँ पर आपको दिया गया है that both the blocks are at rest. ये आपको मान के चलना है because very properly it has been given. This was very clear, but इस case में we needed this additional condition and there it is. अब क्या करेंगे? थोड़ी देर के लिए just assume that the entire surface is smooth. ये आपने assume करना है. Now this is a very very important statement. क्या करना है? You need to assume the surface is smooth. और ये किस लिए कर रहे हैं? Don't forget, we are trying to find the intention of the block, whether it wants to move or not. और एक बार surface आप smooth assume करेंगे, then mentally just imagine whether the motion would be there or not. और अगर motion हो रहा है, then we say yes, there is an intention. Now let's try to clarify. Now right here आपको पता है the block is at rest, there is no relative motion. But then the second part, we want to identify whether there is intention to begin the relative motion or not. तो आप क्या करें, थोड़ी देर मान ले the surface is smooth, बाकी सब condition as it is रहेंगे. You just need to assume that the surface is smooth. तो आप बताइए, if this surface is smooth, will there be any relative motion here? Every condition is same, बस एक change हमने किया है, assume the surface to be smooth. Now when this surface is smooth, आप देखेंगे there is no relative motion. एक smooth surface में if you keep a block, you know that the block will not move. इसका मतलब the block is at rest and there is no intention, okay? There is no intention for motion. साफ पता चल रहा है. कैसे? Assume the surface to be smooth. Let me repeat it again because this is one area where अक्सर आप confuse करते हैं. So let me just remove it. I think if we repeat it multiple times, at the end of the class, you would come out to be a completely, concept cleared student. The surface, block is on the surface. It is at rest, but there is no intention. There is no intention to begin as well. Therefore, there will be no static friction. तो एक चीज ध्यान देना, बस ये कहना कि static friction will act when there is no relative motion is an incorrect statement. देखिए ध्यान से, there is no relative motion, but still there is no static friction. I think you thoroughly understood that, all right? अब जरा यहाँ देखते हैं. Look, it has been given that the block is at rest. तो एक चीज तो पता चल गया that the first condition, it is at rest. That is clear. अब हम identify करेंगे whether there is intention to begin the relative motion or not. और ये block का जो मन की बात, block का जो इरादा है, ये कैसे पता करें? Now we have the technique. थोड़ी देर आप assume करें that the surface is smooth. Assume कीजिए that the surface is smooth. तो आप बताइए, if the surface is smooth, will this block remain at rest or the block will move? Of course, the block will move. यानी अगर ये surface smooth होता, the block would have moved. But हमें पता है the block is not moving in the actual scenario. इसका मतलब block wants to move. Block का इरादा move करना है. But because of the roughness, the block is not able to move. So in this given condition, it is at rest, but there is an intention to move. Move करने का इरादा है. इसका मतलब in this given condition, there will be this static friction. So I think now, intention to move पता करने के लिए there would be no any difficulty. Let me repeat it again because that's going to be a very crucial thing. एक बार repeat करते, that the condition is given that the block is at rest. The first condition has been clear. But हमें अब पता है if there is no relative motion, ज़रूरी नहीं है static friction आ जाएगा. The second condition has to be satisfied. And what's the second condition? There should be an intention to begin the relative motion. और वो intention कैसे पता करेंगे? Assume कीजिए that the surface is smooth. And if this is smooth, you know that the block will be moving. You get my point? As a matter of fact, हमें पता है, in reality, it's not moving, all thanks to the roughness. Roughness के कारण से the block is not moving. But ये चीज तो पता चल गई है that there is an intention to begin. There is an intention to begin. So therefore, you could see that there will be static friction. So just to understand whether there is intention or not, the technique is very simple. If it is at rest, but it would have moved had the surface been smooth, that is the appropriate condition, that there is an intention to move, and that is the condition where static friction will be acting. I hope that has properly made sense, okay? So at least you know the first thing, that's a big achievement. Let's congratulate ourselves. अब हमें पता चल गया कि in what condition there will be static friction, in what condition there will be no static friction. दोनों ही जानना बहुत आवश्यक है कि कब static friction होगा, कब नहीं होगा. Now let's see couple of properties of static friction. The first thing, let's try to understand. Magnitude of static friction is calculated from FBD, the free body diagram. यहाँ पर there is a major difference from kinetic friction. अगर हम kinetic friction की बात करें, then the expression of kinetic friction, how much is it? Say it loud at your own place. Answer post करने की ज़रूरत नहीं है, but tell me, how much is the value of kinetic friction? We have the formula that is mu k times n, n being the normal reaction, mu k being the coefficient of kinetic friction. तो आपने देखा kinetic friction के केस में we do have a formula, लेकिन static friction के केस में we don't have the formula. Let me repeat it again. Static friction के केस में we don't have the formula. तो अगर इसका formula नहीं है तो हम value कैसे calculate करेंगे? And it has been clearly written कि static friction को हम निकालेंगे from the free body diagram. Situation को देखेंगे और free body diagram से calculate करेंगे. So in this regard, static friction की value निकालने के लिए आप दो चार formula memorize करके मैं static friction निकालूंगा, ऐसा सोचना भी मत. You would fall into trouble. You would really fall into trouble. And for those students who have already had an experience of static friction, अगर आप ये कहेंगे that static friction is equal to applied force, that is not always correct. अगर आप ये सोच रखते हैं that static friction is always equal to applied force, let me tell you again, that is not necessarily correct. कहीं पर ये expression fit बैठता है, कहीं पर ये fit नहीं बैठता है. तो कैसे निकालेंगे? We have the answer. We find it from the free body diagram. So that was the first point. Second point is that the static friction is a self-adjusting force. या lot many times इसे हम self-limiting force ये भी कहते हैं. We also call it as the self-limiting force, self-adjusting force. दोनों एक ही चीज है. अलग अलग सिचुएशन में, अलग अलग स्थिति में स्टैटिक फ्रिक्शन की वैल्यू अलग अलग रहती है. सिचुएशन को बेस्ट सेटिस्फाई करने के लिए द स्टैटिक फ्रिक्शन वैल्यू इज प्रेजेंट. इसीलिए वी कॉल इट एज द सेल्फ एडजस्टिंग फोर्स. अनलाइक काइनेटिक फ्रिक्शन जिसका एक फिक्स्ड वैल्यू है, स्टैटिक फ्रिक्शन डज नॉट हैव अ फिक्स्ड वैल्यू. Depending upon the scenario, depending upon the situation, the value of static friction would vary. इसीलिए static friction को हम कहते हैं self adjusting. आगे जैसे जैसे numerical के लिए हम proceed करेंगे, you would get to know that what is the meaning of self adjusting. Now the last point. Although the value of static friction is calculated from the free body diagram, but we have the formula for maximum static friction, and that maximum static friction is also called as the limiting friction. Let me repeat it again. That static friction maximum is called as the limiting friction, and that value is mu s times n. Notice there is a difference from kinetic friction जो कि mu k times n है. The maximum static friction is mu s times n, और इस mu s को हम coefficient of static friction कहते. शायद इसी कारण से lot many students they get confused that coefficient of static friction है, so this is the formula for static friction. वो ये सोचते this is incorrect. This is incorrect. Yes, we call it as coefficient of static friction. In a way, this is the formula for static friction, but with a major change, and that is this is the maximum value of static friction, जिसे हम कहते हैं limiting friction. So I hope with all these ideas, at least lot amount of properties associated with static friction must have been clear. And I'll be quite happy if existing misconceptions would be clear basis the present discussion here. अब हमने देखा when does static friction act. हमने देखा static friction की value क्या है और किस तरह से calculate की जाती है. We also saw that what is the maximum value of static friction. Now there is the next point. What is the direction of static friction? So direction of static friction, that is one point where even the bestest of the students start slipping. तो आइए एक बार इसे understand करते हैं. The direction of static friction. Let's see how it goes. Now there are these points, और ये जो points है ये आपका life saver है. यही आपका मूल मंत्र है क्या करने के लिए? In order to compute the direction of static friction. Let's see how. It says assume the surface to be smooth. Okay, थोड़ी देर आप assume करें. हालांकि यही टेक्निक हमने static friction है या नहीं, whether the static friction is present or not, identify करने के लिए भी we had followed the same technique. Assume the surface to be smooth, and it says see the probable relative motion and oppose that probable relative motion. Now these three steps are going to help you in order to find and identify the direction of static friction. Let us see with an example. An example is always the best way how to identify. Okay, so this is a block, and let's say that this block is present on a ground, and the ground is of course rough. Okay, and I also would say that there is a applied force which is there, and let's say that the applied force is acting here. Okay, so here is that applied force. So this is the applied force. And yes, let me write it very, very clearly that the surface is rough. Now, rough surface पे there is a block, और उस block को हम खींच रहे हैं. We are pulling that block. ज़रूरी नहीं है the block should move, और हो भी सकता है that the block moves. Both the conditions are probable. अभी तक we are not equipped with the method to identify whether the block is moving or not, क्योंकि फिलहाल हमने उस बारे में चर्चा नहीं की है. So let me give you the condition that the block is at rest. ये given है, मेरी guarantee है, keep it there. Alright, now let's go step by step. The first thing is that, is there relative motion? Let's repeat again. Okay, there is no harm in repeating what we have discussed earlier. Is there relative motion? No, there is no relative motion. Is there an intention to begin the relative motion? I think yes. कैसे? थोड़ी देर mentally assume करें that the surface is smooth. Rest all the conditions are same. सब के सब conditions वही है. अब जरा ध्यान से देखिए. Surface is smooth. That we have assumed. Actually में नहीं है, but that's just an assumption. And if I'm pulling it by a force, tell me, will there be a relative motion? The answer is yes. तो हमने देखा smooth surface पे there would have been a relative motion. लेकिन roughness के कारण से there is no relative motion. So what do we say? When the surface is rough, there is an intention to begin the relative motion. ये बात हमने verify कर लिया, ये बात हमने investigate कर लिया. एक बार हमने investigate कर लिया, there is an intention to begin. That means now we have confirmed that there is going to be static friction. There is going to be static friction. Now, what would be the direction of this static friction? That's the big question. So it's quite simple. जब surface smooth था, while the surface was smooth, what would be the probable direction of relative motion? Well, this block would have moved right with respect to ground. That's quite a simple thing. So you got a probable relative motion. अब करना क्या है? Just oppose that probable relative motion. यही काम करना है. So the opposing the probable relative motion, that will be there. That friction is for the block, and this friction is for the, that friction is for the block, this friction is for the ground. And because you know that forces would always appear in action-reaction form. Forces always appear in pair form. So if this value is Fs, this value would be Fs. Equal and opposite. Now the second question is the value of this Fs equals to mu s times n? We said no. We can't say that. Ho sakta hai. I will not deny that possibility. But because we don't know that it is the maximum condition. So agar maximum value hai, yes, we agree that's mu s times n. Filhal ke liye we'll just keep it as Fs. Now when you are taking the block as the system, so you would just be concentrating on this. You would not be concentrating on that. That's a basic idea of free body diagram. अब जरा देखते हैं कि static friction की value कैसे calculate करेंगे. Remember, we had said that static friction is calculated the value from the free body diagram. यानी यहाँ लिखेंगे since the block is at rest. कैसे पता चला? It has been given. क्या हमेशा दिया जाता है? We need to find that condition. धीरे धीरे progress करेंगे. But right now दिया है तो लेने में क्या हर्ज है? So since the block is at rest, अगर block rest में है, how much will be the net force? The net force will be 0. तो net force 0 करने के लिए the value of static friction will be equals to the applied force. And we are done. We are done. अब जरा सोचिए, why do we call it as self-adjusting? मान लेते that I'll take two values of force, 4 Newton, that's first case, second is 6 Newton, और ये मान के चलते, for both the values of these forces, the block is at rest. Okay, हो सकता है? So I said that, okay, at 4 Newton, it's at rest. At 6 Newton also, it is at rest. I have given it to you. Okay, so when it is 4 Newton, the value of static friction would be 4 Newton. When it is 6 Newton, the value of the static friction would be 6 Newton. Yani pehle, when the applied force was 4 Newton, static was 4 Newton. Ab, when the applied force is 6 Newton, the static has changed its value to 6 Newton. तभी जाके हम कहते हैं that static friction is a self-adjusting force. Situation के मुताबिक, स्थिति के मुताबिक, the value of static friction changes. I hope that's perfectly clear. Now you may say that यहाँ पर static friction की value applied force के बराबर है, but थोड़ी देर पहले आपने कहा था that it's not necessary that static friction is always equal to applied force. And I still stand in my position firm and strong. अभी भी मैं यही condition maintain करता हूँ कि static friction की value हमेशा applied force के बराबर नहीं होती है. The value of static friction is not always equal to applied force. At some situation, the static friction may be equal to applied force, and we don't have problem in that. We absolutely don't have problem in that. All right? So you just see, everything is very methodically defined. इसके लिए there is no guesswork required, or most importantly, you need not be stressed. There is a method developed. There is a methodology how you visualize it. Now, let's go for one more problem. My experience is that one block problem, fairly you manage. But the moment we come for multiple blocks, moment we take block over block, 2 रखिए, 3 रखिए, 4 रखिए, if we develop a method, you can put that method, you can reproduce that method for any number of blocks. That's not a problem. So what I'll do is that, let me discuss it for 2 block system. 2 block system के लिए discuss करते हैं, all right? So here it goes. I would take one block here. I would take another block. All right, let me change the color. So these are the two blocks. And I just need to keep the ground as well. So what sort of ground? Green ground. Going green, environment friendly, all right? So, okay, so these are the two blocks. And let us say that this is block A, this is block B. और साथ ही साथ में I have given that a force is applied on the upper block. So this one is that applied force. And I would say that this given surface is smooth. That's perfectly fine. But there is roughness between A and B. And I also give you the condition that both the blocks move together. This has been given. Abhi ke liye, we are developing, we are going step by step. Abhi ke liye, I have given you that both the blocks move together. Slowly, you would be in a position to identify whether the blocks are moving together or not moving together. So let's go step by step, all right? Sabse pehle cheez, you should understand that this is the condition, the game changer, the determiner that both the blocks move together. Now, first of all, tell me, we will concentrate between A and B. Now, the big question is there relative motion? No relative motion. Allow me to write it as RM, relative motion. There is no relative motion. So can I say that there is no relative motion, so there would be static friction? Can I say? Think about it. Meanwhile, I'll sip some water. H2O. Let me get hydrated. All right. So what did I say? There is no relative motion. So can we say that there would be static friction? No. We also have to investigate, we also have to verify whether there is an intention to begin the relative motion or not. We need to investigate that. We need to verify that. कैसे करें? लो जी, आपके सामने है. थोड़ी देर assume कीजिए that A और B के बीच का जो surface है, वो smooth है. Let me repeat it again. थोड़ी देर assume करें the surface between A and B is smooth. कर लिया? तो आप बताइए, when the surface between A and B is smooth, what would be that imaginary relative motion? Of course, A would move right with respect to B. लेकिन हमें पता है that they are not sliding, they are moving together. So what did we see? When there is a roughness, there is no sliding. But when the roughness was absent, A would have slid right with respect to B. तो हमें पता चल गया that there is no relative motion, but there is an intention to begin the relative motion. You get that point? There is no relative motion, but there is an intention to begin the relative motion. और साथ ही साथ हमें probable direction of relative motion ये भी पता चल गया. The probable direction of relative motion is A would be moving right with respect to B. So if that is the situation, now identifying the direction of the friction is not a problem. So here A will have a friction towards left, B would have a friction towards right. And this is Fs and this is also Fs. Equal and opposite. अगर आप अकेले A को सिस्टम लेंगे, this friction will come. आप अकेले B को सिस्टम लेंगे, the lower friction will come. So that is how we identified the direction of the friction. अब जरा magnitude की बात करते, and you are gonna love it. You're absolutely going to love this when we are going to calculate this static friction. कैसे? Let me take my system as A. Let me take my system as A. Now, what would you say? Ground के respect में, let me talk with respect to ground. एक बात बताइए, ground के respect में, A is at rest or moving? You would say, well, A is moving. Why? It has been given. Both the blocks are moving together. So, ground के respect में, A is moving towards right. So, if A is moving towards right, I have a simple question. Tell me, capital F or Fs में से, I'm talking about this Fs, which value would be greater? Of course, capital F would be greater. क्यों? Because the block is moving towards right. यही तो न्यूटन जी महाराज ने कहा है, that if there is an acceleration towards right, there is a net force towards right. That's what Newton has said. So because it is moving towards right, so capital F must be greater than Fs. And if I really want to write the value, what would I write? Capital F minus Fs is equals to mass multiplied by acceleration. Now the big thing is that for those students जो बस आधा अधूरा knowledge लेके जिन्होंने ये बात को याद कर रखा है that static friction is always equals to applied force, you would fall here. You would badly fall here. बुरी तरह से गिरोगे. साफ सी बात है, the value of static friction is not equal to applied force. Now you would say कि ये जो static friction का जो magnitude है, static friction की value निकालने के लिए, can I take block B as a system? देखेंगे. एक simple सी बात है. Even in this simple point, I have found the inability of students to decide कि किसको system लिया जाए. और बहुत आसान तरीका है. There is a very very simple thing. बस ये decide करें किसको निकालना है. रूम के बाहर निकालना नहीं, किसकी वैल्यू निकालना है. Okay? We have to calculate the static friction. तो वो जो Fs क्या B का फ्री बॉडी डायग्राम में अपीयर हो रहा है या नहीं? You would say, oh yes, that Fs is acting or appearing in the free body diagram of B. कहानी खत्म. Because Fs comes in the free body diagram of B, so I can even take B as a system to compute Fs. Because Fs is appearing in the free body diagram of A, so I can take A as a system to compute the value of Fs. And that's what we have done. So चलिए B को एक system मानते. If you see that B is moving towards right, and the only force which is acting on B is this Fs, the lower one, and then you would find that value of Fs is capital M times A. Then a genuine question may arise कि इससे पहले आप कहोगे सर आपने तो ये कहा था कि ये जो static friction की value equal in magnitude and opposite in direction, लेकिन देखने में static friction की value यहाँ और यहाँ अलग-अलग लगता है. ऐसा नहीं है. There is A. The value of A is such कि जब आप रखेंगे you would find, to your surprise, the value of static friction will come out to be same. और वो आना चाहिए, नहीं तो फिर Newton's third law would go into a failure mode, जो कि हो नहीं सकता. So there is A, and that value of A will fit that idea of Newton's third law. All right? Okay, many things have been done. Let's go with one more. So this is the same given situation जिसके बारे में we talked about. This is the same situation जिसके बारे में we talked about. Now, let's see. यहाँ पर this will be the condition. अब आपको decide करना है about the direction of static friction. अभी बहुत ज़्यादा pressure मैं आप पे नहीं डाल रहा हूँ. We'll talk about the magnitude of static friction, but let's simply see the direction. And let me give you the condition that the lower surface is smooth, and the condition has been given that both move together. And if both move together, of course, here there would be friction. तभी जाके दोनों एक साथ चलेंगे, नहीं तो आप just imagine कीजिए, कल्पना कीजिए कि ये surface smooth था. So both the blocks will not move together. नीचे वाला खिसक के आ जाएगा आगे. You get that point? Okay. So now let's say that how do we find? All right, let's go step by step. Methodically चलते हैं. कि is there relative motion between these? No. कैसे पता चला? We have the condition here, both move together. All right, but now we are careful. We need to verify the second condition as well. किसके लिए? to ascertain, to find out whether static friction is there or not. Is there an intention to begin the relative motion? Man ki baat, ek baar pata karte. Let's try to find that. I think yes. Rough surface mein, both the blocks are moving together. But if this surface would have been smooth, of course, capital M would move forward. तो smooth में there is a relative motion, लेकिन roughness के कारण से there is no relative motion. So this means कि when the surface is rough, blocks तो चाह रहे हैं. The blocks are wanting to have relative motion, but the friction is not allowing to have relative motion. So yes, we ascertain there is an intention to have relative motion. अब बारी है probable relative motion, intended relative motion की direction. And that's a very easy thing. हलवा, काफी आसान है. कैसे? That this block would have moved in this direction, so there will be static friction in this direction. There will be, एक काम करते हैं, just to avoid confusion, because I don't want you to get confused in any given point. So there, the static friction would be in this direction. Action reaction equal opposite, magnitude will be equal, the direction that would be opposite. All right, moving further, here's a question now. इससे पहले जो मैं आपको कह रहा था कि अब तक तो मैंने आपको दिया है condition that the block is not moving. I had given you, but now you would grow up. You would grow up and you would find out whether there is an intention or not. ये identify आप खुद करेंगे. कैसे देखते? और आराम से करेंगे. Nothing to worry. Step by step, we will learn the concept. That is the big thing. What's the question here? Mass is 10 kg, mu s की value दी गई है 0.5, mu k की value 0.45. This is a property that coefficient of static friction is greater than coefficient of kinetic friction. So कोई भी question में आपको दिखेगा mu s की value mu k से ज्यादा है. हालांकि lot many times subscript नहीं दिया जाता है, simply लिखा जाता है mu equals to say for example 0.3. अगर ऐसा लिखा हुआ मिले, so this mu would be commonly used for mu s as well as mu k. But you know, these are just for numerical simplicity, but as a matter of fact, the value of mu s is greater than mu k. इसके पीछे एक reason है, let's not go into that. Let's stick to the numerical. All right. So now let's see what does it say. जब force की जो value है, दो condition में we need to find. First, 40 Newton. Second, 60 Newton. दोनों cases में we need to identify the value of friction. Second, we need to identify the acceleration. Third, we need to find the contact force. सब करेंगे. Quite a long bit of question, but we'll do. अब देखो, इससे पहले I was hand holding you. I was giving you the condition that the block is not moving. But now, the responsibility is on us to identify whether there is relative motion or not. और difficult नहीं है. एक काम करना. First of all, what you do is that पहले ही you calculate the limiting friction. But आप कहोगे limiting friction तो तब होगा the maximum value of static friction. Yes, I agree. मैंने ये बात नहीं कही है that the friction acting is limiting. थोड़ी देर के लिए separately write the value of limiting friction. लिख लेना. This will just act as a reference to which we will compare. The limiting friction लिखते, and that limiting friction that is equals to mu s times n. We know that. How much is mu s? 0.5. How much is normal reaction? 10 g. Acceleration due to gravity, let's take it as 10. Let's not make it complex by 9.8. हालांकि उसमें भी difficulty तो नहीं है. So this is 50 Newton. We've calculated the value of limiting friction. Done. First thing we have done. Now, This second thing, इसको भी यूज करेंगे. We have kept it as reference. अब क्या करना है? First condition, let's see, when the force is 40 Newton. इसके लिए देखेंगे. आप क्या कीजिए? assume करें static friction. आप कहेंगे ऐसे कैसे assume करें? How can we do that? तभी तो लिखा है assume. मान लीजिए. I don't know what's the reality. पता नहीं है. थोड़ी देर के लिए मान लेते. This is the static friction. तो उस given condition में what would be the direction of this static friction? Since we have discussed in greater details, I don't find it any point that we repeat it again. ये है, but do remember, I'm still in the condition. I'm assuming it. ठीक है. Now, क्योंकि static friction है, that means there is no relative motion. इसका मतलब, इस assumption के मुताबिक, the value of static friction is 40 Newton और acceleration की value 0 है. But I didn't say that this is the ultimate answer. अभी तक नहीं कहा है. I did not say that this is the ultimate answer. Because there's a big thing which is remaining. And that big thing is that we need to confirm whether that assumption of ours is correct or incorrect. We need to confirm that. How to do that? इस assumption के मुताबिक the value of static friction is 40 Newton. और हमें ये भी पता है, अब काम आ गया, that the limiting friction is 50 Newton. And we also know that limiting friction is the maximum value of static friction. तो सब चीज proper नजर आ रही है कि जो static friction की value 40 Newton है और वो maximum friction से कम है. That means there is no trouble, there is no mistake in this assumption. यानी हमारा जो assumption है वो बिल्कुल सही है. So in case of 40 Newton, the static friction is 40 Newton and therefore the acceleration is 0. ऐसे करते, इस तरह से identify करते whether the block is moving or not. You just see how step by step gradually we have increased and we have found out. शुरू में I gave you the condition, I was hand holding you, but soon now we have reached that position where we can find out whether there is relative motion or not. Now, next thing is that this will be the condition, all right? This second condition when the applied force is 60 Newton. Let's start. क्या इस value में कोई change आएगी? No. Limiting friction, mu s times n, perfectly fine. और ये value कहाँ काम आएगी? In order to compare. That is our reference. That is our reference. ठीक है? क्या assume करेंगे rest? जी हाँ. Force कितना है? 60 Newton. और इस assumption के मुताबिक when there is a static friction, how much will be the value of static friction? Of course, that value would be 60 Newton. That value would be 60 Newton. That's our assumption. But then, we need to justify, we need to verify whether our assumption is correct or incorrect. इसे verify करना है? No problem. Static friction is 60 Newton, but the maximum value of static friction, जिसे हम limiting friction कहते हैं, the value of limiting friction कितनी आ रही है? 50 Newton. क्या सब ठीक है या दया कुछ तो गड़बड़ है? दया कुछ तो गड़बड़ है, because the static friction is coming out to be greater than limiting friction. असंभव, impossible, it's not possible. तो अगर ये possible नहीं है, what does that imply? That implies हमारी जो assumption थी, that is incorrect. हमने जो माना था वो incorrect है. क्या माना था? Static friction माना था. तो क्या करेंगे? No problem. We'll redo it. So now what we'll do is that, since I know that it is now moving, एक बात तो हमने decide कर लिया है, there will be acceleration. Okay. And the second thing is that, how much will be the friction? Now I know that the friction acting will be kinetic friction. And how much is the kinetic friction? Mu k times n. And how much will that value be? 45. That will be the value. तो एक चीज तो हमने decide या find out कर लिया है that the value of friction is kinetic, which is equals to 45. That's great. अब acceleration निकालेंगे. Let's calculate that acceleration. So to find that acceleration is not a problem. 60 minus of 45 is mass multiplied by acceleration. So that value of acceleration will come out to be 1.5 meter per second square. So that is the value of acceleration, 1.5 meter per second square. And we are done. Ab dekhiye, you would fall in love with static friction and eventually you'll fall in love with physics. So methodical it is, ki method by method, step by step, gradually as you rise, you see that every answer is found out. Yes? Alright, so let's go with one more question. Find the minimum force required to move the block. ये एक काफी ज़्यादा फसाऊ problem है. Lot many times students do the mistake. यही question जब हम class में discuss करते, okay, Shanmati, long time no hear from you. Shanmati from Chennai. And yes, perfectly fine. You have kept all the answers. Wonderful, wonderful, Shanmati. So I don't think so my 20% Hindi is being a trouble. Is it so? I need your response. I think you can manage, right? Majority we have kept it in English. Alright, so now let's go to the next one. Find the minimum force required to move the block. Now let's see. Minimum force required to move the block. Don't do this mistake that पहले आप F assume यहाँ करें. Don't do that mistake. The question did not say that the force is acting horizontally. Please don't do that mistake. So what will we do? We will do in this way. Let me assume that F is acting at an angle theta. So what's the strategy? The strategy is that we will not assume F in horizontal direction. बिल्कुल assume नहीं करेंगे. Rather, out of many different angular position, we would find that appropriate angular position for which the force required to move the block would be minimum. So because the question did not say it's in a horizontal direction, we cannot assume that. So I'm losing time a bit, so let me proceed further. This is N, this is mg, and when the block moves, just moving, the friction acting will be limiting. Why limiting? Because I assume that the block is just started to slip. We are calculating the minimum force. Cool. So what will I get the first thing? N plus F sine theta, that is equals to mg. That's in the vertical direction. F sine theta, N plus F sine theta, that's equals to mg. The second is that the value of F cos theta will be equals to mu s times N when the block has started moving. Because remember, we need to find the minimum force required when the block moves. तो उस condition में जब block ने just slip करना शुरू किया है, the friction acting would be limiting, alright? And that value of normal reaction I can replace from the first equation, so that is mg minus of F sine theta. So that is what we have done. Now from these two cases, from this and this, I can see that the value of F is mu s mg divided by cos theta plus of mu s sine theta. That is the value of F. But there is still a big question. The theta is not given. And out of all values of theta, we need to find the minimum possible force so that the block will move. Say theta is not given. We simply assume, okay, let's apply the force at theta. So the second step is that we need to find that theta where the force applied would be minimum. But then sometimes trigonometry helps. You need not find that condition. आप एक simple चीज कर सकते हैं that this force will be minimum when this denominator would be maximum. You're not always lucky to find such beautiful condition, but जहां ऐसे condition मिलते हैं, don't lose the opportunity. Don't lose the opportunity. And I hope all of you know this. A sin theta plus B cos theta. This given function will have a maximum value of root of A square plus B square. It's a basic property from trigo. If you don't know that, just get updated. So right here, F minimum is going to be equals to mu s mg. All right, let me show you the property as well. A sin theta plus B cos theta. You could see A is mu s, B is 1. So the maximum value would be 1 square plus mu s square. So that is the minimum possible value of force so that the block would move. A little pinch of trigonometry, little dash of trigonometry was there, and you need to get used to with that. जब आप JEE level के problem solve करते हैं, simple trigonometry should be in your fingertips. So I promised you that in today's class we're going to master upon static friction, magnitude and direction, and I've done that. I'm pretty confident. Thanks for joining me. I'll catch you up in the next one. Till then, take care. Bye-bye.